In this video, we will be looking at the derivative in applied contexts that are not motion. In the previous video, lesson 4.2, we looked at the derivative in the context of motion, so position, velocity, and acceleration, but in this video, we're going to be applying that concept of the derivative to other situations. First, we will be extending our knowledge from lesson 4.1. So instead of just interpreting a given derivative value that they gave us, like they did in lesson 4.1, we're now going to be finding that value and interpreting it. Let's jump right into the first problem. This is a calculator free response question. Let R of t represent the rate at which cattle enter a pen. R of t is equal to e to the power of sine of 0.2t plus 2 over t plus 1, where R is measured in cattle per minute and t is measured in minutes. I'm going to underline a few key things. First, I need to know what this function represents. This function represents the rate. So this is not the number of cattle. This is the rate at which cattle are entering the pen. I also want to take a look at my units. It says R is measured in cattle per minute and T is measured in minutes. So in part A, when it says find R of 5 using correct units, interpret this value in the context of the problem, the first thing I'm going to do is I'm just going to get R of 5. And because this is a calculator problem, thank goodness I don't have to calculate this manually. I can just get out my graphing calculator and plug 5 directly into that function. So instead of writing t, I will write a 5. So I will have e to the power of sine of 0.2 times 5 plus 2 over 5 plus 1. And that gives me 2.653. So when I write down my answer, I can round or truncate to 3 decimal places. R of 5 is equal to 2.653. Now I need to interpret this value in the context of the problem. If we just plugged in 5 to the R function, our units are going to be the same as the function for R. So we know that this is representing the cattle per minute. And we also need to clarify, well, at what time is this happening? This means that at time t equals 5, the cattle are entering the pen at a rate of 2.653 cattle per minute. Now let's do part B. Part B says find R prime of 5. Using correct units, interpret this value in the context of the problem. So first, when I find R prime of 5, the way that I'm going to do that on my calculator, since I'm trying to take a derivative, I'm going to hit math and then number 8. That's going to get me something in the form of d dx of a function at x is equal to a specific value. So first, I will say d dx. You could do d dt, but I think it's easier just to do x in the calculator so that you don't have to be switching around your variables. As long as you keep it consistent, the calculator does not care whether it's x or t. Then right here, we need to input the function for r. So I will do that. And then what value of x are we trying to find r prime at? Well, we're trying to find r prime of 5. So at the end, we say x is equal to 5. And this gives us 0.195. Again, round or truncate to 3 decimal places. Now, what does this mean? First, let's think about what are the units for the derivative. We can find the units for the derivative by taking the units for r and putting them over the units for t. So in this case, the units for the derivative, r prime, would be cattle per minute per minute. So we're talking about how is the rate increasing or decreasing at time t equals 5. Since r is already a rate, this is the rate of change of the rate. To do my explanation, I would say at time t equals 5 minutes, the rate at which cattle enter the pen is increasing by 0.195 cattle per minute per minute. Here is my answer for the first free response question. Let's do another free response question. During a chemical reaction, the amount of substance remaining in grams at time t in minutes after the start of the reaction can be modeled by the function a of t is equal to this function. The first thing I'm going to note is my units. So amount of substance remaining in grams, that's the units for a of t, and then t, time, is in minutes after the start of the reaction. Part A says find a of 15. Using correct units, interpret this value in the context of the problem. Finding a of 15 is very straightforward. We just need to go plug 15 into this function using the calculator. Then we get 1.816, and you can either round or truncate your decimal. I'm going to truncate it here, so I will say 1.816, and then we need to interpret this value in the context of the problem. Well, since we're just dealing with a and we're not dealing with a derivative of a, the units for a of 15 will be the same as the units for a of t, which we know was grams. So I will say at time t equals 15, or 15 minutes after the start of the reaction, the amount of substance remaining is 1.816 grams. There's my answer for part A. Now let's move on to part B. Part B says, is the amount of substance remaining increasing or decreasing at time t equals 6? So essentially, is A of t increasing or decreasing at time t equals 6? Justify your answer. Here's a brief reminder from lesson 4.1. If a function's derivative is positive at a certain time, that means that the function itself is increasing at that time. And if the function's derivative is negative at a certain time, the function would be decreasing at that time. So in order to determine whether A of t is increasing or decreasing at time t equals 6, we need to find A prime of 6. We need to find the derivative so that we can analyze the behavior of that function. So how do we find A prime of 6 in the calculator? Well, whenever we're trying to take a derivative, you need to use math number 8, and that will get you into the format d dx of some function at x is equal to some number. So at this point, I'm just going to type in my function for A of t right here. And it's perfectly fine to use x here. The calculator doesn't care whether it's x or t as long as you're keeping the variable consistent. And then we're trying to find it at x is equal to 6, or at t is equal to 6, so plug in 6 right there. And that gets you negative 0.329. So I will write that number down. A prime of 6 is equal to negative 0.329. Since this value is less than 0, it means that A of t will be decreasing at time t equals 6. So for my justification right here, I will say the amount of substance remaining is decreasing at t equals 6 because A prime of 6 is less than 0. If you want to, you can also indicate over here that A prime of 6 is less than 0, or you could even stick a less than 0 right there on the end. Those are all acceptable ways of showing that the function itself will be decreasing. Part C says find A prime of 10. Using correct units, interpret this value in the context of the problem. When I go to find A prime of 10, I'm going to show you a nice shortcut for the calculator. Because we have already plugged in our function for A into the math 8 function, all that you need to do is go up to and then hit enter to click that one down again. But then instead of finding A prime of 6 like we were up here, we're now finding A prime of 10. So just replace that 6 with a 10. And that will give you the new value, which is negative 0.275. Now, what does this mean in the context of the problem? To find the units for the derivative, we can take the units for the original function, which was A of t, so grams, and stick it over the units for time. So grams per minute. So what A prime of 10 means in the context of the problem, it means that at time t equals 10, or you could say 10 minutes after the start of the reaction, the amount of substance is decreasing, because this value is negative, by 0.275 grams per minute. There's my completed response for part C. Let's do a sample multiple choice question. The rate at which oil leaks from a bottle is modeled by R of t, where R of t is measured in milliliters per hour and t is measured in hours. Suppose R is differentiable on the open interval from 0 to 24. What is the best interpretation of R prime of 10? And then we have these options here. It could be the rate at which oil is leaking from the bottle at time t equals 10 hours, the rate of change of the rate at which oil is leaking from the bottle at 10 hours, the amount of oil in the bottle at 10 hours, or the amount of oil that leaked out of the bottle from t equals 0 to t equals 10. Well, I know that it's not going to be these amount ones because we are dealing with a derivative here, and a derivative is a rate, so it's going to be either A or B. Now, since R of t itself is already a rate, R of t we know is going to be measured in milliliters per hour, so if we are finding R prime of t, that would be measured in milliliters per hour because it's the derivative of the rate. Therefore, B is going to be the correct answer. R prime of 10 represents the rate of change of the rate at which oil leaks from the bottle in milliliters per hour at t equals 10. Choice A looks very tempting because that's another rate. It says it's the rate at which oil leaks from the bottle in milliliters per hour at 10 hours. However, this would be R of 10 because remember, R is already a rate. So A represents R of 10, but B represents R prime of 10, which is what they were asking for. The number of individuals in a gymnasium at time t is modeled by the twice differentiable function p of t, where p is measured in people and t is measured in hours after 8 o'clock a.m. Let p of 2 be equal to 133 and p prime of 2 be equal to negative 6. Which of the following correctly identifies whether the number of people in the gym is increasing or decreasing at 10 a.m. and provides a correct justification? If I'm trying to determine whether the number of people is increasing or decreasing, I know that P represents the number of people, so P prime of T is going to tell me whether the number of people is increasing or decreasing. If P prime is positive, that means the number of people are increasing. If P prime is negative, that means the number of people is decreasing at time T equals 2. So 10 o'clock a.m., that would be at time T equals 2 because it's 2 hours after 8 o'clock a.m. I can see that P prime of 2 is negative 6. So P prime of 2 is less than 0. Therefore, I know that the number of people in the gym will be decreasing at 10 a.m. So I can eliminate answer choices A and B. Now I need to pick the correct justification. Is it because P prime of T is less than 0, or is it because P prime of T is less than P of 2? Choice C is correct because I'm only looking for whether P prime of 2 is positive or negative. I don't care about what it is compared to P of 2, the number of people in the gym. Therefore, C is the correct answer. Occasionally, in these types of problems, there will be two rates. There will be an in rate and an out rate, and we'll look at an example of that in just a second. When you see an in rate and an out rate for the same time interval, compare the two rates at the given time, which they will give you that time, to determine whether the amount is increasing or decreasing. So the proper justification format for this would be the amount of blank, whatever it is, maybe it's water, maybe it's oil, maybe it's number of hippos in a certain area. The number of blank is increasing at time T equals whatever they gave you because the in rate minus the out rate at those times is greater than 0. Or we could say the amount of the stuff is decreasing at time T equals something because the in rate minus the out rate is less than 0. So if the in rate minus the out rate is less than 0, it's decreasing. If the in rate minus the out rate is greater than 0, the number of things or the amount of stuff is increasing. Let's take a look at an example of an in rate and out rate type problem. Water is being added to a bucket at a rate modeled by A of T is equal to this function. For 0 being less than or equal to T being less than or equal to 60, water is simultaneously or also leaking from the bucket at a rate modeled by L of T is equal to this function on that same interval from 0 to 60. Both A of T and L of T are measured in liters per minute, and T is measured in minutes. So both of these are rates. Is the amount of water in the bucket increasing or decreasing at time T equals 15? Justify your answer. So let's just think about this one logically for a moment. If the rate at which water is being added to the bucket is greater than the rate at which water is leaving the bucket, that means that the amount of water will be increasing. If the amount of water that's being added to the bucket is less than the amount that's draining out, the total amount of water would be decreasing at that time. So what we need to do is we need to find some way to compare A of 15 and L of 15. How I'm going to do that is I'm going to take the in rate at 15 minus the out rate at 15. So I will say A of 15 minus L of 15. A is the in rate of the water, L is the out rate of the water. And I need to figure out what that is. So when I plug that in, I will just first plug in 15 to the A function, and I get this number. But then I need to subtract L of 15. So I need to do minus, and then I need to plug in 15 to this function. So it would really just be e to the 5th right there. And it gives me this, negative 143.996. So I'm going to jot that down. Then I need to determine whether this is greater than or less than 0. When I recopy this, I will say A of 15 minus L of 15 is less than 0. This means that the in rate is less than the out rate. The out rate must be larger in order for us to be getting that negative number. The out rate needs to be larger than the in rate. Therefore, this means that the amount of water in the bucket at time T equals 15 would be decreasing. So I'll just write out my justification for that. At T equals 15 minutes, the amount of water in the bucket is decreasing since A of 15 minus L of 15 is less than 0, which means that the rate at which water drains from the bucket is greater than the rate at which water enters the bucket at time T equals 15. This bracketed section here, that's optional. All that you really need on your paper to get the points for this free response would be having some comparison between A of 15 and L of 15, but I think this is sometimes helpful to clarify as well, even if it's just to convince yourself that that is the correct answer. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T, where T is measured in hours and 0 is less than or equal to T is less than or equal to 8. At the beginning of the workday, so at time T equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, which is from time t equals 0 to time t equals 8 inclusive, the plant processes gravel at a constant rate of 100 tons per hour. First, find g prime of 5. Using correct units, interpret your answer in the context of the problem. Finding g prime of 5 is not difficult, especially since this is a calculator problem. I just need to hit math 8, and then I will be able to say d dx, plug in this function with x, and I want it to calculate the derivative at t equals 5. So I hit the 5 in there, and that is equal to negative 24.587. Now I need to interpret the answer in the context of the problem. Remember, g of t is already representing a rate. It's the rate in tons per hour. So in order to find the units for g prime of t or g prime of 5, we need to take the units of g of t and put it over the units for t. So tons per hour per hour. So this means that the rate at which unprocessed gravel is arriving, or the rate at which gravel arrives, is decreasing by 24.587 tons per hour at time t equals 5. At t equals 5, the rate at which gravel arrives is decreasing by 24.587 tons per hour. Now, part C says, is the amount of unprocessed gravel increasing or decreasing at time t equals 5? Show the work that leads to your answer. So the in rate and the out rate are a little bit more confusing here. I know that this is going to be the in rate because this is the rate at which the gravel is arriving. So I will just circle this and label this in. But what's the out rate? What is the rate at which it's leaving the plant or at which it's being processed? Well, it says the plant processes gravel at a constant rate of 100 tons per hour. So this rate, the rate at which it's leaving, is 100 always. So that is my out rate. Therefore, this time I need to compare g of 5, the rate at which it's arriving at t equals 5, to 100 to see whether that is less than or greater than 100. So first I will find g of 5, the rate at which gravel is arriving at the plant at t equals 5. So I'll just plug that into my calculator. And that is 98.140. You can either round or truncate, equals 98.140. And then I need to compare that to 100 tons per hour, my out rate. Well, I know that this is going to be less than 100. So my justification will be at time t equals 5, the rate at which gravel is arriving, or g of 5, is less than 100. Therefore, the amount of gravel at the plant is decreasing at time t equals 5. Here's my justification. At time t equals 5, the arrival rate of the gravel, g of 5, is less than the processing rate, 100. And I should really have some units on there. I should say 100 tons per hour. Thus, the amount of unprocessed gravel is decreasing at time t equals 5. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t on the interval from 0 to 12, where f of t is measured in pounds per hour and t is the number of hours after the store opened. This is going to be our out rate. This is the rate at which bananas are being removed. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t, but this is only occurring from 3 to 12. So this is my in rate, but it's occurring for a shorter period of time than my out rate. And it says g of t is measured in pounds per hour and t is the number of hours after the store opened. Part B says find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. To find f prime of 7, that's pretty straightforward. I just need to grab my calculator and I will do math 8 because I'm taking a derivative. So hit math and then number 8, d dx of, and then I just plug in this function right here, f of t. I will use x's in the calculator, which is fine. And I'm trying to find it at t or at x is equal to 7. So that is negative 8.119. And then I have to think about what does f prime actually represent? Well, f is already a rate, so it's going to be the rate of the rate, or the rate of change of the rate. So this means that when t is equal to 7, or after the store has been open for 7 hours, the rate at which bananas are leaving the display table is going to be decreasing by 8.119, decreasing because this number is negative, by 8.119 pounds per hour. Part C says, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. So this is another classic in rate and out rate problem. We're being asked about the number of pounds of bananas on the display table, and is that increasing or is that decreasing at time t equals 5? Because both of these windows include 5, we are going to have to use our in rate and our out rate. So first, let's do the in rate at 5 minus the out rate at 5. This would be g of 5 minus f of 5. We're trying to compare the in rate and the out rate at t is equal to 5. So I'm going to put this into my calculator, plugging in 5 for g, and then subtracting, plugging in 5 for f. So that would be g of 5, and then I need to subtract f of 5. And that gets me negative 2.263. Because this value is less than 0, I know that the number of pounds of bananas on the display table is going to be decreasing at time t equals 5. Because the in rate minus the out rate is less than 0, that means that the out rate is going to be greater than the in rate. So overall, the amount will be decreasing. Five hours after the store opens, the number of pounds of bananas is decreasing since g of 5 minus f of 5 is less than 0.